Small and medium enterprises are facing a severe escalation in legal liability. The European Union has introduced the Cyber Resilience Act, or CRA, and the Network and Information Security Directive, known as NIS2. The CRA focuses on secure-by-design requirements for hardware and software products, while NIS2 establishes a baseline for risk management across critical sectors. When tested against this regulatory weight, informal compliance documentation instantly collapses. Most small organizations lack the resources to implement a full ISO 27001 Information Security Management System, or ISMS. And ISMS is a systematic approach to managing sensitive company information so that it remains secure. It involves over 100 specific security controls. For a lean team, the headcount required to manage this system is a mathematical impossibility. Faced with this resource gap, a common industry reflex is to use generative AI as an ad hoc productivity tool. Companies prompt large language models to write security policies, generate risk statements, and fill out compliance questionnaires. Relying on conversational prompts to generate security policies leads directly to audit failure. The resulting text blocks are isolated fragments. They lack a defined scope, they cannot be traced back to specific framework clauses, and they provide no operational continuity when a system fails. To survive regulatory scrutiny, artificial intelligence must function as governed, rigid infrastructure. Organizations fail compliance audits when they lack operationalized controls. The policies might exist on a server, but if they are not actively used to measure risk or report incidents, they do not meet the regulator's standards. The solution is a Minimum Viable Compliance Skill Stack, or MVCSS. This is a lean set of specific AI skills engineered to force operational consistency. By deploying a restricted library of targeted skills, an organization can achieve approximately 80% coverage of CRA and NIS2 expectations without the administrative overhead of a full ISO 27001 implementation. This stack addresses the three highest priorities: legal exposure from fines, operational risk from downtime, and the immediate ability to provide an auditor with evidence of active security work. For this to work, the AI can no longer generate amorphous paragraphs of text. Every interaction must result in strict, structured data. Engineered schemas and rigid formatting are required to translate large language model capabilities into legally binding regulatory evidence. The minimal skill template is the structural foundation that eliminates open-ended prompting. It provides the rigid container for every compliance task. Every skill explicitly states its regulatory mapping. This provides the auditor with the specific framework clause or legal article the AI is addressing, ensuring the output is contextually relevant. The instructions block forces the AI to apply specific regulatory logic to the provided inputs. This prevents the model from guessing based on average industry practices. The prompt then dictates a strict JSON or data table schema. JSON, or JavaScript Object Notation, is a standard text-based format for representing structured data. By demanding this format, we ensure the output can be integrated into other governance tools. The most critical component is the validation layer. This implements explainability by design. It ensures that the logic behind every compliance decision is visible to an external reviewer. This layer forces the AI to execute a completeness check and state a definitive confidence level for the structured data it just generated. The model must also explicitly flag any missing data or open assumptions it made before finalizing the output. This atomic structure shifts the AI toward producing validated, audit-ready evidence artifacts. We can map these atomic skills across multiple regulatory domains using a crosswalk table. While ISO 27001 focuses on continuous management controls, the CRA mandates secure-by-design accountability across the product lifecycle. Structured AI skills bridge this gap by translating a single technical input into evidence that satisfies both frameworks at once. For example, consider the Risk Assessment Engine skill. This specific skill fulfills the risk assessment mandate of ISO Clause 6.1.2 while simultaneously meeting the CRA's requirements for risk-based cybersecurity design. The engine produces a data row linking an asset to its specific threat and vulnerability. It then calculates a risk score based on likelihood and impact. Crosswalking these requirements ensures the organization generates precise operational treatments for security risks, rather than just redundant paperwork. These core 8 skills form a functional governance system. These skills are engineered to feed into one another as a closed-loop workflow. Node 1 is scope and asset definition. You cannot legally secure or report on an environment you haven't formally bounded. The structured output from the scope definition becomes the direct input for Node 2, the risk assessment engine. Node 3 is the minimum security controls mapper. It translates the identified risks into actionable baseline measures for the technical team. Node 4 is incident classification and reporting. This skill is required to meet the strict 24-hour and 72-hour reporting deadlines mandated by NIST 2. To maintain integrity, the system utilizes a human-in-the-loop design pattern. At each node, a human must explicitly validate the AI's JSON output before the data can pass to the next phase. This chained dependency transforms static AI prompts into a dynamic, interconnected management system. Node 5 is vulnerability intake and patch prioritization. This skill addresses the CRA mandate for coordinated vulnerability disclosure. It calculates CVSS severity scores to dictate exactly which patches take priority. CVSS, or Common Vulnerability Scoring System, is a free and open industry standard for assessing the severity of computer system security vulnerabilities. Node 6 is supplier risk assessment. Supply chain security is a primary enforcement target under NIS2, requiring constant evaluation of third-party vendors. Node 7 is the audit evidence generator. This standardizes the collection of security artifacts to prove the organization is following its own policies. Node 8 is the management briefing generator. This fulfills the NIS2 requirement for executive accountability by summarizing risks and required decisions for board members. The decisions made in Node 8 trigger a re-evaluation of the business scope in Node 1, beginning the cycle again. This cyclical flow aligns with the CRA's requirement for continuous lifecycle security. This closed-loop architecture seamlessly integrates essential compliance directly into the daily workflow as a continuously running operational engine. We can now evaluate the real-world impact of this 8-skill stack. By addressing the essential requirements of the Cyber Resilience Act, this system captures approximately 75% of an organization's core CRA obligations. For NIS2, these nodes cover the primary risk management and reporting mandates, delivering roughly 65% of the required operational baseline. Several areas are intentionally excluded from this minimum stack, such as advanced cryptography governance and full-depth supplier audits. Omitting these elements is a strategic advantage for SMEs. It prevents framework bloat and allows the team to maintain immediate visibility over their highest risk areas. Implementation occurs in phases. Deploying scope, risk, and incident skills in Phase 1 provides immediate visibility into the company's legal exposure. Adding evidence and management briefing skills in Phase 3 renders the organization audit-ready within 12 weeks. Modern regulatory enforcement now demands evidence of continuous risk management over theoretical perfection. Auditors want to see a functioning system that an organization actively uses, rather than a pristine framework that was simply copied and ignored. Utilizing this structured AI stack embeds compliance into the organization as operational discipline. It ensures that risks are visible, decisions are documented, and accountability is perfectly traceable.